Hello, grade 9s, and welcome to MV Tutors. I'm Tselo, and I'll be helping you revise for your Term 1 test. All right, so we're going to look at a paper from last year, 2023, and hopefully this will help you in preparation for your first term test this year, 2024. So without wasting any time, let's get to question 1. So it says, classify the following numbers as natural, whole number, rational, non-real, irrational, non-real, or rational. Okay, so what is the difference? When you have natural numbers, those are from, let me just put it here. Natural numbers are from 1 up until to infinity, right? Then you have whole numbers. Whole numbers start from 0. Just going to say WN. Whole numbers. Whole numbers are from 0 all the way to infinity. Then we have, let's just first deal with integers, even though they didn't ask about integers, but let's just state integers are from negative infinity all the way to positive infinity. And then let's address rational numbers. So rational numbers are numbers which can be written as a fraction, all right, where that fraction, if you have x over y, both x and y are integers, okay, and y cannot be equal to 0. All right, so rational numbers, they can be written as fractions. They can also be recurring decimal numbers. Remember, recurring is if you have a number and let's say 2, 3, and the 3 is recurring. It keeps occurring. That's what recurring means. Those are your rational numbers. And then you get your irrational numbers. Okay. Actually, rational, let me use what is normally used. Okay, so we said natural numbers, then you get whole numbers, and then you get rational, then irrational. Okay, this is much better, right? So irrational numbers are numbers that cannot be written as a fraction, all right? And also, irrational numbers can include decimal numbers that do not recur, okay? So for example, like the square root of 5, okay? That's one of the examples I can give for rational numbers. And all of these form part of the real number system, okay? Real numbers, which includes all these rational numbers. Remember, rational also includes whole numbers, natural numbers, integers. So real numbers include rational as well as irrational. And rational, they include natural, whole numbers, integers. Okay, I hope you're still with me. I know I'm taking a while, but we need to define this. Then we get non-real numbers. So those non-real numbers are imaginary numbers. All right. So what are those imaginary numbers? Well, let's say you have a square root of negative 5. If you put that into your calculator, it will tell you it is a math error. Okay. So yeah, that's why we say it's imaginary numbers. And I think after defining all of that, we are ready then to answer the questions. So what is negative 27? Negative 27 is an integer, right? But they didn't list integers here as numbers. So we can say that negative 27, it cannot be natural. It definitely is not whole number. It is not irrational. So we can say it's a rational number. All right. Then 1.2, we have the square root of 21. Okay, square root of 21. Yeah, so we can't really write that as a fraction, so we can't say it is irrational. So in this case, it would be irrational. All right, then 1.3, we have 2, 3 recurring. We already, yeah, and I used, oh gosh, I didn't even realize I used that as an example, but I must have seen it before, hence my mind remembered. So 2, 3 recurring. In this case, that is a rational number. Okay. And then 1.4, we just have a basic number 11. That is Well, it is a natural number because it forms part of this range over here from 1 to infinity. We could also say it's a whole number. So yeah, what will we say? I think we can say natural, or we can say a whole number. But then again, it's also a rational number, so yeah, more than one option available. So it's either natural, or it's either a whole number, or it's either rational. Okay, now 1.5. Square root of negative 9 does not exist, guys. Okay, it does exist. It's an imaginary number. Imaginary. Okay, so that is basically non-real. All right, and I think we are done with this question. Okay, 1 mark each. That should have been a nice recap from grade 8 work. And now we get to question 2. All right, so question 2.1 says, find the highest common factor. Okay, so we have 24 x cubed y z to the power 4. Just gonna do some dotted lines over there. And then we have 30 x squared y squared z cubed. And then lastly, we have 36 x cubed y squared z cubed. All right, I'm going to deal first with the whole numbers that we have there. Okay, so remember the factors of 24. We have 1 and 24. We have 2 and 12. We have 3 and 8. We have 4 and 6. And I think that's it. With 30, we have 1 and 30, 2 and 15, 3 and 10. 4 is not divisible. 5, yes, and 6. 7, 8, 9, nope. So that's it. And then with 36, we have 1 and 36, 2 and 18, 3 and 12, okay, 4 and 9, I believe we can always check. Yes. 5, no, 6 and 6, and that's pretty much it. So what is the highest common factor here? All right, without even looking very far, yeah, I see 6 as the highest common factor. All right, check again. There's 12 here, there's 12 there, but there's no 12 in 30. I think that's it. 6 is the highest common factor. So at least we have our whole number 6. Now let's go with x. So this x cubed, x squared, and x cubed. So x squared would be the highest common factor, right? And then let's go to y. We have y there, y squared, y squared. So y is the highest common factor. And z, we have z to the power 4, z to the power 3, z to the power 3. So z to the power 3 it is. And that is our highest common factor. Now what about 2.2? It says determine the lowest common multiple of 150, 250, and 375. Okay, so let's list the multiples of 150. So we have 150 plus 150, we get 300, plus 150, we get 450, plus 150, we get 600. I'm just going to list 3 terms. No, maybe let's list 6 terms, and then we'll see as we go. So 600 plus 150, that's 750. 750 plus 150, that is 900. And maybe I'll stop there with the multiples of 150. Now let's go to 250. 250 plus 250 is 500. 500 plus 250 is 750. 750 plus 250 is 1,000. I think I'll stop here. 375 will actually tell me if I should go further. So what is 375 times 2? Guys, you can use your calculator. I also have mine out. Yeah. Okay, so we have 750. Let's just make sure. Yeah, we have 750. So we have 375 and 750. So do you see there's no need for me to go on because we're looking for the lowest common multiple. All right, actually, let me write my answer like this. Let me shift this and say the highest common factor, HCF, is equal to, and now the lowest common multiple here, common one, 750. All right, now question 3. It says simplify the ratio 154 to 132 in its simplest form. That's 3.1. So we have 154 is to 132. So we normally list the factors here. Okay, the first thing I'm going to do, 2 is definitely a factor. I think 3 is as well. But geez, if I list all the factors, when am I going to finish? So let's do this. Grade 9s, let's say 154. I'm going to try 9. I'm guessing here. 9 is not going to work. I know 3 will work. Oh, no, it's not working. Oh, no, 3 won't work. 3 won't work because if I add these numbers up, 1 plus 5 plus 4, that's equal to 10. 10 is not a factor of 3. Okay, so yeah, 3 will not work. How about 4? 6? No. 8? No. My goodness. Okay, let's do this. I think we're going to have to do this the hard way. So let's list the factors. I have 1 and 154. If I take 2, what do I get? 77. I know 3 doesn't work, 4 doesn't work, 5 doesn't work. 6, did I test it? Yes, it doesn't work. 7, 8, no. 9, 10, 11, 12, no. 13, no. 14, yes, 14 works. Okay, maybe I should start with 11 and 14. Okay, I'm going to stop there a little bit. Let me go to 132. So 132 divided by 2, I get 66. Then 11 should be a factor. So 11 and 12. Okay, so I didn't really labor that much like I thought I would. Now, what is the question again? Simplify the ratio. So then I would say 154 divided by 11. And I have 132 divided by 11 because in both cases that is the highest common factor. So 154 divided by 11 gives me 14 and 132 divided by 11 gives me 12. But no, I'm not done actually. I can still go on because we really want to write it in its simplest form. So 14, if I were to divide that by 2, so actually I think 22 is the highest factor. I didn't test it. So 154 divided by 22. So actually 7 is a number that I missed because if I had put 7 there, I would have seen that it's actually a factor. And then 132, let's see what 132 divided by 22 is. It's 6. I did not test it. You see, if you miss something, it will reveal itself. So basically, the highest common factor is not 11, it's actually 22. So we have 154 over 22, 132 over 22, and we know we have 7 is to 6. Okay, that is the simplest it can be. Or you could have done it like me, missing what we missed, and you would have said, okay, 11 is the highest common factor, but then you get to a point where you have 14 is to 12, then you need to divide by 2 again. So then you have 7 is to 6. At the end of the day, both answers are correct. Maybe you might get penalized for not seeing that 22 is the highest common factor, but I doubt it. Now, 3.2, it says increase 700 in the ratio of 3 is to 2. So far, the work that we have been doing is actually grade 8 work. So if you missed any of these topics, you can go to the grade 8 content and have a look. Now, when we increase, we take our ratio, write it in fraction form, but an increase will write the biggest value in the numerator and the smallest in the denominator. So what is 700 multiplied by 3 over 2? So 700 times 1.5, it's actually 1050. Cool. And now 3.3, it says decrease 117 kilogram in that particular ratio. So we have 117 kilogram, and whenever we decrease, we write the smallest number in the numerator and the largest one in the denominator. Okay, that's simply that, and then we multiply. So we have 117 multiplied by 10 over 13, and we get an answer of 90 kilograms. All right, that's 3.3. Now 3.4, it says 3 boys share 2,100 in the ratio 3:5:7. Calculate how much each boy will get. Again, if you forgot anything about ratios, go back to the grade 8 content, you will be sorted. So firstly, we're going to add up 3 plus 5 plus 7. 3 plus 5 is 8. 8 plus 7 is 15. Okay, so what we're going to do, we're going to say 3 over 15 multiplied by 2,100 rands. Then we have 5 over 15 multiplied by 2,100 rands. And then lastly, we have 7 over 15 multiplied by 2,100 rands. And what do we get? Okay, so we have 3 over 15, multiplied by 2,100. And we get 420. All right, and then the second one, we have 5 over 15. So in a calculator, just going to change that. And then you get 700. Then lastly, it'll be 7 over 15. And that's 980. And that's it. But you also just need to check. If you take 420 plus 700 by 980, do you get back the original amount? Yes, we do. 2,100. Okay, so that was 3.4. Now 3.5 says, Michelle and Temba are traveling from Cape Town to Johannesburg by car. That is a very long trip. So they travel 30 kilometers in 18 minutes, and they continue at this constant speed. How far will they have traveled in 1 hour, 38 minutes? Okay, so basically, they traveled 30 kilometers in 18 minutes. What we want to do here, we need to multiply by some minutes, okay? And before we do that, we need to convert this 1 hour 48 minutes into minutes. So we already have 48 minutes, right? How do I convert 1 hour to minutes? Well, I know that 1 hour is 60 minutes. So this is just the side calculation that I'm doing. So 48 plus 60, I then have 108 minutes. So that's something that we do. So now we know it's 108 minutes. Okay. So maybe this is something we would have done on the side or below or some way. But we need working space. So now what are we going to do? 30 kilometers times 108 minutes divided by 18 minutes. Okay, because at the end, the question they ask is how far will they have traveled? So they want distance, and we can leave it in kilometers. Okay, they didn't ask it in meters or anything, so just leave the answer in kilometers. So now we have 30 multiplied by 108 divided by 18. Okay, because the minutes are going to cancel, and then we're left with kilometers. So our answer will be in kilometers. And we see that actually they would have traveled 180 kilometers. Okay, which is a fraction of their trip. But yes, that is it. Guys, if at any point you don't understand something, please do put it in the comment section. And while we're at it, please don't forget to like our videos and also subscribe to our channel. All right, now we get to 3.6. So it says the table below shows the cost in rand for liters of milk. All right, so copy and complete the table. So we have liters of milk there. 1 liter, 2 liter, then they skip to 4 and skip to 6 and blah, blah, blah. Then we have the cost in rand. All right, so if I'm just gonna say liters there and then cost in rand. Let me just draw this table. All right, so we can see for 1 liter, it was 8 rand, all right, and 2 liters, it was 16 rand. So we moved from 8 to 16, it was plus 8. And then we jumped to 4, all right, but 4, we can see that it was 32 rand. Okay, and I don't know if you see the trend here, but here I see that if I say 8 times 1, I get 1. If I say 8 times 2, I get 16. Sorry, 8 times 1, I get 8. 8 times 2, I get 16. And if I say 8 times 4, I actually get 32. So I believe that this trend, I need to add 8 all the time. So if I had 3 liters, then 3 times 8 would have been 24. Okay, so every time I need to add 8. If I had 5 liters, then 5 times 8 would have been 40. Okay, and 6 liters, so I would say 6 times 8. What would I get? I would get 48. All right, so that's one of the numbers that we should fill in. Okay, so I know here this is what I need to fill in. 48. And what about 64? What times 8 will give me 64? Well, it's actually 8. All right. And what is 8 times 12? Okay, so that would be what, 96. All right, so those are the missing numbers. Okay, and we can see that every time we need to add 8. All right, to move on to the next number, provided there aren't any missing values. All right, so that is the trend. Now that's 3.6.1. 3.6.2 says, what type of proportion is this? Okay, so here, if you were to sketch this graph over here, it's more of a linear relationship, okay? And in terms of what type of proportion it is, well, here we sort of like have a numeric pattern, okay? So, yeah, we can then say it's a numeric pattern. So yeah, this is a numeric pattern that is quite linear, all right, because you can see that we are increasing the amount of liters and also the amount of rands are increasing. So it's a positively linear numeric pattern. All right, but they asked, what type of proportion is this? Okay, is it inversely proportional or directly proportional? So if it was like a negative relationship, then it would be inversely proportional. But here, it's, positively linear, so it is directly proportional. Just one mark. Directly proportional. Now, yeah, 3.7. So it says the table below shows the number of hours that men take to complete a particular task. All right, so here we can see, so 3.7.1, copy and complete the table. All right, and what can we see? What can we notice here? We notice that as the amount of men increase, the hours to complete the task decreases. Okay, so if ever they ask about proportion, which they do in 3.7.2, it's basically inversely proportional. All right, but anyway, let's draw the table and fill it up. All right, so let us complete the table. So I see if there's one man, it takes 8 hours to complete, right? And if there are two men, it takes half the time. All right, so here one man, and then the next one, two men, it takes half the time. So here I can say 8 divided by 1, I get 8, and 8 divided by 2, I get 4. Here for number 4, 4 men, 8 divided by 4, okay, I get 2. All right, 2 hours to complete, we have 4 men. So I see the trend here, all right? It's quite similar. The numbers there, 1, 2, 4, 6, and 12. So for 3.6, we could see that we keep adding 8 all the time. But here, what we do, we take 8 and we divide by 1. Secondly, we take 8, we divide by 2. Here we take 8, we divide by 4. So that's the trend that I keep seeing. You just start with 8 hours, which is normal, and then we keep dividing by the number of men. All right, so then for 6 men, I would then say 8 divided by 6, because I have 8 hours, so divided by 6 men. And if I simplify the 8 over 6, so the highest common factor there is 2. So then I have 4 over 3. Okay, so here I will have 4 over 3. Now, how much do I need to divide 8 by, okay, in order to get 4 over 5? All right, so what number am I going to use? Number of men will I use? Okay, so this is what we just filled in, and I fill in there so that you know the difference. All right, so what I'm going to do in this case, I know I need to say 8 divided by something, and then I'm going to get 4 over 5. Okay, so this is typically just solving. All right, so what am I going to do? I'm going to multiply by x on both sides. So then I have 8 is equal to 4x over 5. And then I'm going to multiply by 5 both sides so that these 5s can cancel. Then I have 4x. 5 times 8 is 40. So if I divide by 4 both sides, I know that x will be equal to 10. So basically here I have 10. Okay, so if I say 8 divided by 10, if I simplify that, dividing by 2 as the highest common factor, I will then have 4 over 5, which is what we have. And then lastly, for the number 12, number of men. So I have 8, and I'm going to divide by 12. 8 hours, now we have 12 men. All right, so if I simplify that, I'm going to divide by 4 both sides, because that's the highest common factor. So 8 divided by 4 is 2, and 12 divided by 4 is 3. So here I can say 2 over 3. Yeah, so you would have started by saying it's 8 over 12, or you would have divided by 2 as your common factor, not the highest though. Then I would have gotten 4 over 6. And then if we simplify further, we get 2 over 3. So that is us filling up the table. All right. So yes. Now let us answer the next question, which we did discuss, 3.7.2. So what kind of pattern is this? It's giving geometric pattern vibes, but the thing with a geometric pattern is you need to constantly divide or multiply by a certain number. All right, so here in this case, I can't really say we are multiplying by a certain number or dividing by a certain number. The trend that we are seeing, however, is that we keep saying the hours to complete, which is 8, starting off with 8, and we divide by the number of men. So 8 divided by 1 is 8. 8 divided by 4 8 divided by 2 is 4, 8 divided by 4 is 2, 8 divided by 6 is 4 over 3, and so forth. Alright, so now what type of proportion is this? We see that as the number of men increase, the hours to complete decrease. So basically this is inversely proportional for this pattern that almost looked geometric. So inversely proportional. Now we can get to question 4. Do you still have a long way to go? Oh no, we're left with question 4 and 5. Okay. Question 4. It says in this question, you are not allowed to use a calculator and you must show all your calculations. Alright. 4.1. So I see we have the cubed root of negative 27. If you don't remember what happens when you have squares, roots, cubes, and cubed roots, please do check out the grade 8 video. We've covered that. So now you have the cubed root of negative 27 minus the square root of 36. So the cubed root of negative 27 is just going to be negative 3. The square root of 36 is going to be 6. Okay, so basically we have minus 3 minus 6. And at this point in time, you can use a number line if you have forgotten how to do it. Let me show you quickly. So let's just say that's minus 3. Okay, minus 4, minus 5, minus 6, minus 7, minus 8. But by this time in grade 9, you guys should be sorted, right? Minus 10. So if I go from minus 3 and I subtract, it means I'm going to the left. And I'm going to go to the left 6 units. So 1, 2, 3, 4, 5, 6. So my answer will be negative 9. Okay, and that was a nice 2 marks. And then 4.2, it says between which consecutive integers does one square root of 130 lie? So this is where you need to know your square roots, okay? Yeah. So basically, I have square root of 130, okay? Remember, we have a square root of 144 and we have a square root of 121, okay? If you know all your square roots, you know that 11 squared is 121, 12 squared is 144. So basically, between which two consecutive integers does 130 lie? It lies between 11 and 12. And we can check with the calculator. They said don't use the calculator for calculating, but you can always use a calculator to check your answer. So square root of 130, what is that? 11,4. And 11,4 is definitely in between the integers 11 and 12. Now we are at 4.3. So it says calculate the following. So we have a cubed root of this long sum. Well, not that long, but then we have 73 minus 3 squared. Okay, let's take it step by step. So we have cube root, 73 we're leaving, and then we are subtracting. What is negative 3 squared? Again, if you don't know, go to that video for grade 8 content that deals with exponents, the squares and the cubes. So negative 3 squared will be 9. Okay, and now we have 73 minus 9. Okay, what's 73 minus 9? That is 64. And you should identify at this point in time that the cubed root of 64 is actually 4. The square root of 64, however, it's 8. And if you're not sure, check. The calculator is there to check, okay? So just check your answer and you will see that it is 4. So that's 4.3. Now 4.4, it says we have 1. So now we have a square root of 1, 44 minus the cubed root of 0,064. What I would suggest, please take these decimals and write them as fractions. So 1,44 is 144 over 100. If you're not sure, check. That's what the calculator is there for. So 144 over 100 is 1,44. Great. And that's a square root. Minus the cubed root. 0,064 is the same as 64 over 1,000. But if you're not sure, check. So, is this yes, it is. So great. Now we can work out. So what you can do, you can separate it and say square root of 144 over the square root of 100 minus the cubed root of 64 over the cubed root. You know you're allowed to do this, right? Don't act surprised now. You know this. So as the square root of 144, that is 12. The square root of 100 is 10. Cubed root of 64, we just did it, is 4. The cubed root of 1,000 is 10. So now we have a fraction and we are going to subtract fractions. The nice thing is our base is the same, so the calculation is pretty much straightforward. 12 minus 4 is 8, and then we have 8 over 10. In what form do they want us to leave it in? They didn't say, and it's just 2 marks. I'm doing a lot actually. If I simplify it, I'm going to get 4 over 5. Or if you write it in decimal, it's just going to be 0,8. Okay, it's up to you. And now we can do 4,5. Alright, so for 4.5.1, it says we should evaluate and give our answer as a fraction in its lowest terms. And this is 1 mark. So if I see a 1 mark question, I'm thinking you can just use a calculator. Alright, but let's just say you don't have a calculator. Obviously, you're going to do a lot for 1 mark. So I'm going to do it without using the calculator. And when it comes to fractions, if you don't know how to deal with fractions, please watch the fractions video. So if you're going to add or subtract fractions that have different denominators, what we do, we multiply the denominators first. So 8 times 10, that's 80. And then we cross multiply. 7 times 10 is 70. 7 times 8, I think that is 56. So we're going to have 70 minus 56. All right. And we're going to get 14. So now you have 14 over 80. All right. If I were to simplify it, I would say 2 is probably the highest common factor. So 14 divided by 2, that's 7. And 80 divided by 2, that is 40. All right. Otherwise, you could have just done it on the calculator. It's 1 mark. I would suggest you use the calculator because you're going to save time. But in the event of not having a calculator, at least then you would know how to calculate it. Alright, so you can see there it's 7 over 40. Okay, then 4.5.2. We have mixed fractions. Alright, and it says give your answer as a mixed number. Alright, so firstly, before we do anything with mixed fractions, I would suggest, highly recommend, actually command you to put it as an improper fraction. All right, so we have 2 and a third multiplied by 3.5. So what are we going to do to turn the mixed fraction to an improper fraction? We're going to say 2 times 3 plus 1. 2 times 3 is 6 plus 1 is 7 over 3. And then here we have 3 times 2, which is 6 plus 1. That's 7 over 2. And the nice thing about fractions is that we can multiply the numerators and multiply the denominators, and we leave it at that. Okay? Why did I put a 2 here? It's supposed to be 7. So 7 times 7 is 49, and 3 times 2 is 6. Okay? Now they want the answer as a mixed number. Okay? What is 49 divided by 6? All right. So the nearest, if you have 6 times 7, that gives you 42, right? So that is the most. No. 42 plus 6 is 48. So actually 6 times 8, okay? That will give us 48. So this will fit. And then you're left with 1. So remember with the mixed fraction, once you have the 8, that is your whole number. The remainder is your numerator. Okay, so we have 8 and 1, 6. That's the mixed number. Now 4.5.3. Yeah, wow, and that was just 1 mark. Okay, guys, let's see. If you were to do it on a calculator, if you have a Casio, you can put in the mixed fraction. I'm just looking for one here. So shift, there we go. We have 2, 1 over 3, and we're going to multiply it by 3, 1 over 2. I just want to see if it's going to give it to us as a... No, it doesn't give it to us as a mixed fraction. It gives it to us as an improper fraction. So if I say shift that... no, it doesn't. It doesn't. So anyway, the answer was 49 over 6. Yeah, you'll have to know how to change from improper to mixed fraction. Okay, now 4.5.3. So we have, let me just see, is it a plus or a division? It's a plus. It looks like a plus. So we have 24 plus 6 plus 2 times 9. Remember BODMAS? We first start with brackets of, then we go to multiplication and division. So we're going to start with 2 times 9, which is 18. And then we can add all of them. So 24 plus 6 is 30. And then plus 18. And that will just give us 48. We can also just put everything in the calculator. Say 24 plus 6 plus 2 times 9. And that gives you 48. This is all one... What? 1 mark. Oh, that's 2 marks. But this is weird. How can 4.5.2 be 1 mark? And 4.5.3 be 2 marks? Hey. Anyway, 4.5.4. We have 0.4 times 0.02. I suggest you put these decimal fractions as your normal common fraction, okay? So 0.4 is the same as 4 over 10, and 0.02 is the same as 2 over 1,000. And then it makes things a bit simpler, because with fractions, if you're going to multiply fractions, you're going to multiply the numerators together. Then you're going to multiply, ooh, did I say 1,000? It should be 100, 2 over 100. Then you should multiply the denominators together. So 4 times 2 is 8, and 10 times 100 is 1,000. Should we leave our answer like this? I think you can say 0.008. And if you're not sure, you can always check. So 0.4 times 0.02, and it's 0.008. Okay, now the last question. They're also giving 1 marks. 1 mark each. I feel like they're stingy. It says calculate the following without the use of a calculator. Alright, now that I've read that, question 4, just use the calculator, okay? Saves time. So you have negative 8 squared plus negative 2 cubed. So what is 8 squared? That's 64. So you have negative 64. And what is negative 2 cubed? It's going to give you negative 8. Okay, because it's negative 2 times negative 2, which is positive 4. Positive 4 times negative 2 is negative 8. And here, what is negative 64 minus 68? Well, because both are negative, I would ask myself, what is 64 plus 8? And that gives us 72. So therefore, we have negative 72. And then when we come to 5.2, we have a mixed fraction, okay? So we have 2.5 plus 1 1/3. We're going to have to write this as improper fractions. So 2 times 2 is 4 plus 1 is 5. 1 times 3 is 3 plus 1 is 4. So now we have 2 improper fractions with different denominators. So we're going to use our rule. We multiply the denominators. 2 times 3 is 6. And then we cross multiply. 5 times 3 is 15. 2 times 4 is 8. And there's a plus in between. And what is 15 plus 8? Well, 5 and 8 make 13. Carry 1, 23. Yeah, so anyway, that is 15 plus 8 is 23. And we're going to divide that by 6. You can either leave it as an improper fraction or write it back as a mixed fraction. So 6 goes into 23 how many times? I think 24 divided by 6 is 4, but 23 is less than 24. So 6 times 3 is 18, right? 23 divided by 6. Then we have that. And then what is 23 minus 18? That should give you 5. No? Yes, should give you 5. So then when we finalize it, it's going to be 3. And then the remainder, 5. So 5 over 6. Okay. Guys, you can always use the calculators to check. Alright? So I would then ask you, if you check with your calculator, are we getting the correct answers? If yes, just comment below with the yes. If we're not getting the right ones, say no and provide the correct answer. Alright, now we have 2 and 2/3. Is this divide? Yeah, this is divide. Now I'm wondering here. There's 24. I think it's 24 divided by 6 for 4.5.3. But anyway, we have 2 and 2/3 divided by 1 and a 9th. So we're going to change this to improper fractions. So 2 times 3 is 6. 6 plus 2 is 8. 1 times 9 is 9 plus 1 is 10. Remember what we do with division. We keep the first fraction the same. We change the division to multiplication and we swap the numerator and the denominator. So now we can go ahead and multiply. So we're going to have 8 times 9 in the numerator, 3 times 10 in the denominator. So now we have 72 over 30. How many times does 30 go into 72? It goes in twice. Okay, it goes in twice. And what is the remainder? The remainder is 12. Please don't try to simplify this. The operation will change entirely. Okay, let me pause a bit. All right, now before we even go to the next question, I just want to look at 4.5.3. Just in case we had a division. So let's say this was 24 divided by 6. Now here's the thing that you always need to ask yourself in a test. If you're uncertain of something, ask the moderator or whoever, not the moderator, but the invigilator, what the sum is saying, because this looks like a division sign, actually. So 24 divided by 6, that is 4. And 2 times 9 is 18. So this answer could have been 22. Okay, so just check there. All right, and then the last question that we're doing, which is 5.4. We have the cubed root of negative 1 over 8 minus 2 and a quarter, the square root of 2 and a quarter. So the cubed root of 1 over 8 will be 1 over 2, negative 1 over 2, okay? Because we have negative 1 over 2 times negative 1 over 2, which gives us positive 1 over 4, multiplied by negative 1 over 2, which gives us negative 1 over 8. You see, ne? So that's cool. We have the cubed root then. And now, I would suggest we change this mixed fraction to an improper fraction. So 2 times 4 is 8 plus 1 is 9. So we have 9 over 4. That's the square root. Okay, and you can then write it. Sorry about that. I got distracted with someone flushing. And I was like, no, how can you flush? I'm recording. It's going to come out in the recording. But anyway, so how do we deal with the square root of 9 over 4? We're just going to say square root of 9 over square root of 4. So we have negative a half minus, so the square root of 9 is 3. We are assuming that we're looking at the positive square root. And this is only 1 mark, okay? Because for a square root of 9, you can actually, you can actually have positive or negative 3, honestly. So, but let's just stick to the positive one. There's actually a meme that I saw that someone was trying to save one of the options, okay, for square root of 4. Was he going to save 2 or negative 2? And he saved the positive 2, not the negative 2. I'll see if I can get a picture of it before I close this session. So yes, square root of 9 is, we're going to take the positive 3, and square root of 4, 2. All right, so at least we have the same denominator. So in that case, we can say minus 1 minus 3, and that's going to be minus 4 over 2, which is simply minus 2. And like I said, you can always check these calculations that we did in the calculator. They're all for 1 mark, although they said calculate without the use of a calculator. But yeah, that is it. Let me find that meme. Okay, I found it. So basically this is the meme, and it comes from, if you have x squared is equal to 4, how you solve for x, you're going to square root both sides. Okay, so in here you have x, but the answer that you can get for the square root of 4 is plus or minus 2. So now this guy is like, oh my gosh, I have 2 of them. Who am I gonna save? It's like, I'm definitely going with a positive 2. I'll leave the negative 2 behind. Okay guys, but anyway, this is the end of the paper. I hope you enjoyed it. I got disturbed quite a couple of times, so sorry for the interruptions in between, but I hope the studying actually goes well for your tests. And yeah, that's it from me. Don't forget to like our videos as well as subscribe to our channel. If there's anything we can improve on, please do tell us so that we can serve you better. All right, bye.